Dear listener, when the usual paths to funding and recognition become tangled, innovation demands clarity, not just in vision, but in tools, language, and direction. At Biodesign Academy, we understand that researchers, founders, and designers often face a landscape riddled with administrative fog and missed opportunities. That's why we've crafted BioFund Scout GPT, an AI-powered assistant built to help you navigate the EU funding terrain with purpose and speed. Whether your work lies in biodesign, synthetic biology, climate tech, or sustainable materials, this tool simplifies your search. It helps you identify calls from Horizon Europe, EIC, and national funders tailored precisely to your technology and TRL. It doesn't stop at discovery. You'll also get guidance in locating partners, identifying proposal benchmarks, and aligning your work with the core goals of the EU Green Deal, including climate action, biodiversity, and circular economies. Most importantly, it provides evaluator-style feedback to strengthen your proposals before you submit them, because good ideas deserve to be funded, and sometimes the difference lies in how you tell the story. Now, let's turn to another story, one unfolding at the edge of machine learning and molecular imagination. Much of the conversation around AlphaFold focuses on structural precision. And yes, accuracy matters. But there's something quietly powerful about the folds it gets wrong, the areas with low confidence scores, irregular loops, or unresolved regions. We call these alpha faults. Our upcoming deep dive explores these so-called faults not as errors, but as invitations. What if those unpredictable regions were seeds for creative design? Functional cues waiting to be translated into new material behaviors, interaction patterns, or structural innovations? Especially for designers and researchers working with cellulose, algae, fungi, and microbial materials, alpha faults could open new doors, not just scientifically, but aesthetically and ethically. In our foundational tier article, we'll walk you through how to annotate these regions as if you were sketching with protein structures, and how this might reframe your regenerative design workflow. But innovation doesn't happen in isolation, and it certainly doesn't happen without access. A quiet but pressing challenge looms over the molecular design space. Starting June 28, 2025, the European Accessibility Act will come into force. While many think of it as a policy for websites and public services, its reach extends further. Every digital tool serving European users, including the molecular modeling, protein folding, and biodesign software your lab might rely on, will need to meet strict accessibility standards. The uncomfortable truth is this: most of those tools were never built with inclusion in mind. They assume the user can see, manipulate complex visualizations, and interpret color-coded molecular interactions without assistance. If you are blind, visually impaired, or neurodivergent, many of these tools become unusable. This isn't just a compliance issue, it's a profound waste of talent and creativity. Biodesign, at its heart, is a discipline committed to life, and yet we are systematically excluding brilliant minds from shaping its future. That's why we're helping labs, educators, and companies transition toward truly inclusive biodesign platforms. From accessibility audits and interface redesigns to inclusive curriculum development, we offer support to ensure your tools don't just meet legal standards, they meet human ones. If you'd like to stay ahead of these changes, explore experimental tools like BioFund Scout GPT, and receive original insights every week. Sign up to our free newsletter at biodesign.academy. We publish in-depth analysis, funding strategies, and creative provocations for the biodesign frontier, all grounded in research, design integrity, and care. Until next time, remember, true innovation does not just reach the future, it reaches everyone.